the graph of a function that satisfies the given conditions. So we were given all this information. F of 0 equals 0, so that means we have a point at 0, 0. We have f prime of negative 2 equals f prime of 1 equals f prime of 9 equals 0. That just means that our critical numbers are negative 2, 1, and 9. Then it tells us that the limit as x approaches infinity, f of x equals 0. So that means we have a horizontal asymptote at y equals 0. And then as the limit of x approaches 6, we have f of x equals negative infinity, and that means that as you approach 6 from both sides, you have a vertical asymptote at x equals 6. This is going to approach infinity from both sides, negative infinity. Okay, then it gives us, as f prime of x is less than 0 on the interval of negative infinity to negative 2 to 1 to 6 and then 9 to infinity, it's going to mean that it's decreasing because it's less than 0. And then as f prime of x is greater than 0 on the intervals of negative 2 to 1 and then 6 to 9, it means that it's going to be increasing. And then the second derivative, we have f double prime of x is greater than 0 on the intervals of negative infinity to 0 and 12 to infinity. That means that it's going to be concave up. And then f double prime of x is less than 0 on the interval 0 to 6 and then 6 to 12, and that means that it's going to be concave down. So now that we have this information, we can start graphing it. So I already did our x and y value, x and y axis, and then our asymptotes. We have one at y equals 0 and x equals 6, and I counted by ones. Okay, so we have our critical numbers at negative 2, 1, and 9. Okay, so now we can look at the information they gave us. So it's going to be decreasing from negative infinity to negative 2. So we can go negative infinity to negative 2, which is here. It doesn't tell us our y value, so we don't really need to know it. We can just kind of sketch it. And then it's going to also be decreasing from 1 to 6. So we'll do as it's increasing from negative 2 to 1. So it's going to be increasing from negative 2. Oh, it's going to go through 0, 0. Don't forget that. So, okay. So it's until 1, it's increasing. And then from 1 to 6, it's going to decrease. So 1 to here. So we'll just go, and remember it's an asymptote, so it goes to negative infinity. And then it's going to increase from 6 to 9. So again, 6 to 9. So I'll just go above the x-axis for now. And then, where was I? 6 to 9, and then 9 to infinity, it's going to decrease. So, and remember we have an asymptote here. Okay, so then we have to go back and make sure it's concave up or concave down. So as f double prime of x is greater than 0, so it's going to go from negative infinity to 0. It's going to be concave up, so I have that. I don't need to fix that. From 0 to 6, it's concave down. So from 0 to 6, I don't have to change that. It's concave down. From 6 to 12, it's also concave down. So 6 to 12, it's concave down. And then from 12 to infinity, it's going to be concave up, so we have a point of inflection right here. And that's your graph.